Welcome back to Arduino for Amateurs. This is episode 3, Putting It Together. My name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the Bidhaven Hackerspace. And in this video, I'm talking about combining the things that we learned in episode 1, which is about hardware, episode 2, which was an introduction to software, to talk about how we build a full Arduino project, right? How we build software that interfaces with hardware to do something. So a brief recap. In our first video, we talked about hardware. This is a solderless breadboard. It's a prototyping component that we use for quickly connecting components to build a circuit. You can see here we've got a red wire coming in from off camera. That's going to be our power lead. That is connected to the rail here, the power rail, the red positive rail on the outside of this breadboard. That is also connected to this jumper wire, sometimes called a DuPont wire, that comes across here to 26. So this row of tie points is all connected electrically. So the power will go from here to this end of this resistor, which is also in row 26. It will go across the trench, the depression here in the middle of the board. It'll move from there to the anode, the long leg of this LED. LEDs, remember, are directional. We have to put power through them in the proper direction. The power will then pass through the LED to the negative, the ground rail on this side of the breadboard, which is connected to this black wire, which we assume is connected to ground. So if this circuit is all set up properly, we should have power come in here, go through here, through our resistor, through our LED to light it up, and then back to ground. And as we saw, when we connected it to a 9-volt battery, that's exactly what happened. The power flowed through the circuit and lit up the LED. So that is the hardware side of the circuit. On the software side, in episode 2, we talked about the Arduino IDE and this very simple snippet of example code called Blink. And what Blink does is it turns on and off pin number 13 on the Arduino board. Pin number 13 is connected to a built-in LED that's part of the board. And we saw that when we flashed the Arduino, when we ran this code on it, that LED would turn on. It would stay on for 1,000 milliseconds, for 1 second. And then it would turn off. It would remain off for 1,000 milliseconds, for 1 second. And then it would turn back on, right? And if we look at the code here, that makes sense. In setup, we initialize the hardware and we say we are going to use pin 13, that LED built-in pin, as an output. Then in the loop, the actual body of the program, we set pin 13, we set LED built-in to high. That means turn it on, wait for 1,000 milliseconds, turn it off, wait for 1,000 milliseconds, and then we're at the bottom of the loop, so we go back up to the beginning. Very simple program. And when we flashed the Arduino with that code, we saw here this amber lamp, this amber LED was blinking. It was on for 1,000 and then off for 1,000. We also have this power LED. This is also on. And when we transmitted the data in there, you see the TX and RX LEDs here, those were flashing as well. But the one that the blink code is actually addressing is this one. Now, we know that that LED is connected to pin number 13, which is right here. So if we want to hook the Arduino to something on the outside, something that will be affected by this program, we need to connect it to pin number 13. So that's what we do here. This circuit is a connection between our Arduino and our breadboard circuit. So this is the same breadboard circuit that we had before. I removed that jumper wire, and I'll explain why in a moment. So we've just got 2 wires. We have a red wire coming from pin number 13 here. It's plugged into the socket labeled 13. I don't know who manufactured your Arduino, but on this particular one, 13 is printed both on the board here, and it's also printed on the outside of the socket over here, so you can see it from the outside. There's a wire connected to socket number 13. That is connected here to row 26. Row 26 is then connected to our resistor. Our resistor is connected to row 26 on the other side of the trench. Row 26 is also connected to our LED. Our LED is connected to the ground rail, and then the ground rail is connected back here to this socket that says ground. Now, you may remember in our first video, we talked about how all of these sockets over here are power related, right? We've got a 3.3 volt socket here, we've got a 5 volt socket here, and then we've got this voltage in socket, and we have a couple of grounds. So you might be thinking to yourself, because that's what you call yourself, why isn't anything connected to any of these power pins here? Nothing is connected to the 5 volt or the 3 volt. I thought that had to be connected to the power rail to make the circuit work. Well, for larger circuits, that is the case. If you need more than a few milliamps, then you're going to need to connect a higher amperage 5 volt or 3.3 volt pin to your circuit. In this case, because we're only powering one LED, we're able to power that directly off of pin 13. Pin 13, when we use that digital write to set it to high, puts out about 40 milliamps. Not a tremendous amount of power, but it is enough to light an LED. So that's really all we need. So what's going to happen? When we run blink, it's going to set pin 13 to high, which means that our LED here is going to light up, our built-in LED on the board, and it's also going to push that 40 milliamps of power across here to our breadboard, where it should go through our resistor and then go through our LED and light it up, right? And when we plug it into USB, you can see that is exactly what happens. Right here, our LED is turned on, and also our blue LED that is part of the circuit is lit up. Right, so this is our first successful circuit. The Arduino is controlling some hardware that is outside of itself, right? It's generating that signal on pin 13, pushing it out to the breadboard, and then the electronics on the breadboard are doing the rest. They're moderating it with the resistor, they're putting it through the LED, and then they're taking that current back to ground through the black wire. This is not the most complicated circuit in the world, but this is a big step forward for us because we are using software inside of the IDE. We are pushing it to the Arduino, and then the Arduino is interacting with something outside of itself to cause something to happen. In this case, to cause that LED to light up. Now, this is interesting, because we're making something happen, but it's also very limited. If we want to affect how this circuit behaves, if we want to keep the light on for longer or vary how long it rests, we're not able to do that unless we plug that USB cable back into a computer, update the code, reflash the Arduino with the new code, and then again, we have a simple static display. If we want the LED to flash jingle bells or SOS or whatever, we can do that, but it's going to be the same every single time. It's kind of boring. So what we're going to do in our next video is we are going to introduce some interactivity. We're going to add a button to our circuit here and see how we can use that to affect how the LED behaves, right? We can set it so that when we push the button, the light is on, or when we release the button, the light is off, or we can set it up as a toggle. Right? We'll see how we do both of those things. So that'll be coming up in the next episode. I'll see you there.